Okay, so the question reads, a shape that covers an area A and has a uniform height h has a volume. So a shape that covers an area A has a uniform height and the volume V is equal to AH. So the question, show that V is dimensionally correct. Then B, show that the volumes of a cylinder and a rectangular box can be written in the form of V is equal to AH, identifying A in each case. Note that A, sometimes called the footprint of the object, can have any shape, and that the height in general can be replaced by average thickness of the object. So this is the question. These are the questions they want us to answer. So how do we go about it? First, you have to know what are they talking about. They're saying this question is V is equal to AH is dimensionally correct. So this question is coming from dimension analysis topic. So let's answer. Alright, so we have now to prove. So this is the formula. V is equal to AH. V is equal to AH. So we have to prove that this formula is dimensionally correct. So we have, for the formula to be dimensionally correct, the left hand side just wait a bit. The left hand side so the left hand side must equal to the right hand side. So when left hand side and right hand side are equal, then the formula becomes dimensionally correct. So what is the formula for volume, or the dimensions for volume? So dimensions for volume is L cubed. Then the right hand side is the one which is AH. So we have to prove that left hand side and right hand side are equal. Then we'll conclude that they're dimensionally correct. So we continue. So we'll start with right hand side. Right hand side, we have area. The dimension for area is L is equal to L squared. So that's the dimension for area. So yes. So then height, the dimension for height is equal to L. So when you multiply L squared and L, it will give us the L cubed. So at this point we can tell that right hand side, left hand side and right hand side here, they are equal. So at this point we can say hence the equation is dimensionally correct. So we can now go to question B. So question B, we are supposed to prove that, or we are supposed to show that the volume of a cylinder is also given by the base area and height. So we have to look, we know how the cylinder looks like. So this is somehow the diagram of how a cylinder looks like. So we know that the base here, it's in circular shape, so meaning base area, now the base area, it's a circular shape, so the area, it will be pi r squared, then height, which is this one, this is the h. So we can tell that in the volume for cylinder, it's pi r squared h. Therefore pi r squared, that's base area, which is a in this equation. Then height is the same height, so we can say that the volume of a cylinder can also be written in this form. Where we continue to answering question C now. So volume of a rectangular block, so volume is equal to LBH. So this is the volume for a rectangular block. So LB, that's the formula for area, then height is the h. So we can tell that we can say volume is equal to, what is area, it's a, what is h, it's height. So we can tell that the volume of a rectangular block can also be written in this form. So at this point we have answered this question. Thank you for watching.